Kinectrics provides lifecycle management solutions for the electricity industry, and my role is to oversee the reverse engineering program. Reverse engineering is a process of taking a legacy item and finding out what the critical characteristics of that item are that need to be met in order for it to meet its safety function. Essentially remaking something from the past. Value engineering is a subset of reverse engineering, but you're improving the device. Take, for example, electronics. We can't buy the same components that they used in 1970, so we rebuild something new with the latest and greatest. So it's not an exact replacement, but it still serves the same form, fit, and function. We would start off almost with a discovery, or as I call it, a treasure hunting phase, where you would look at all the legacy documentation, all the plant literature, the system drawings. If you can, you would get a surplus sample. Any assumptions that you would have, you would test the surplus sample to validate those.
You start with the block diagram of the original unit, so that gives you a blueprint for what you want, and then you fill in those blocks with modern components that are available.
We'll initially design the product electrically and mechanically. We'll build prototype samples. We do an alpha, beta, provide them to the customer and get concurrence and approvals on the design. In terms of design, one of the key areas to keep the project on track is to engage the customer, have frequent meetings.
Communication with the client is very important. You want the client to understand every decision and be on side with every decision, so he is not surprised when you deliver the final product.
Once the beta design is solidified, we'll move on to the qualification stage, and the product will be qualified and tested.
So the reverse engineering lab here at Kinectrics is able to reverse engineer and build almost any electrical or mechanical device. So we get into everything from circuit board design, metal enclosures, 3D printing of the plastics. We'll do injection molding. We can make coils, we can make magnets. In my opinion, today with the technology of materials we have, we can actually build better products than what they were able to build 30 years ago. Kinectrics is uniquely positioned for reverse engineering in that we have our dedicated reverse engineering team of project managers, designers, technicians, builders that understand how to capture the requirements, design a product, and qualify it. But we're also supported by the size of Kinectrics and all of the research and academia that is here.
There's just a whole range of people that are required for the team, and that's one good thing about this group. There's a very strong team, strong people that do the job really well.
The client is guaranteed to have a fully qualified, functioning product with complete set of documentation so they can install it in their station that'll last for the next 30 years.
For an average widget in a panel, replacing the panel might be multi-million dollars. In a lot of applications, it's actually cost-effective to just replace the component to preserve the wiring, the panel. If we reverse engineer something, then they don't have to retrain their people at site. So there's a lot of cost savings from a documentation, from a training, from a certification standpoint by keeping it the same. Being able to reverse engineer something, not changing the failure modes, not changing the footprint, reusing the existing wiring has the potential to save a lot of money.